Hello guys, welcome back. In this video, what we will learn? We will learn the evolution, why this embeddings based NLP era got evolved and what happened during that era with some programming examples, and we also discuss what are the limitations that we face in this era and what is the next era of NLP methods or NLP evolutions. Now let's understand why this embeddings based NLP era came. The reason for this is, so from ML based era, how we are visualizing our data from neural networks. If we consider from neural networks, how we are visualizing our data or text, we are passing our data or text to these neural networks in the form of vectors. How in a numerical format, in numerical representation, we are passing our data. That numerical representation is nothing but we call it as vectors. If we pass the data in the form of vector to our neural networks or ML based models, then we can able to learn relations as well as patterns effectively, and we can able to identify the whole sentence. You can see we can able to capture the context, and we can able to handle new words as well if we pass our data in the form of vectors to our neural networks. So there is a huge requirement to convert our word or sentences into vector format before passing our data to our neural network. So during that time, there is a huge demand of these converters, that is from word to vector converters. For these word to vector converters, there is a huge demand. So that's why this embeddings based NLP era evolved. Instead of word, so can we define it like a data from the text data to vector conversion requirement is there. So in order to fulfill that requirement and convert the text data into vector data effectively, these embeddings based NLP era has revolutionized. So in this era, multiple text data to vector conversion models are evolved. So among those, let us discuss some famous models. In this embeddings based NLP era, mainly two types of embeddings were developed. One is word to vector conversion embeddings. So during the initial days, word to vector conversion embeddings were developed, and further on, later, these contextual based embeddings are developed. In this word to vector based embeddings, for the given word in a sentence, the vector is developed or the vector embeddings are developed. Whereas in this contextual based embeddings, for the whole context, for the particular word, embeddings were developed, or you can say vectors were created. Now let's see some famous embedding models which were developed to this word to vector embeddings. And we also see the famous contextual embeddings as well. For this word to vector based embeddings, majorly two embeddings becomes very famous at those time. Those are embedding model that is developed by Google. That model is Word2Vec. That Word2Vec model is a famous model that is developed by Google. The task of that model is Word2Vec embeddings creation. By this model, how actually vectors are predicted. So during that time, Google folks developed this model. So at that time, two main models in this Word2Vec was developed. First one is Seabow and second one is skipgram. So what is the Seabow and what is the skipgram, sir? In this technique, in this Seabow technique, actually we will predict how we will predict a word. We will predict a word based on surrounding words. Based on surrounding word embeddings, we will predict the current word. Whereas in this skipgram, what we do? We can able to predict surrounding words by using the given word. Based on the given word, surrounding words are predicted. So these are the two models in this Word2Vec. After this Word2Vec, in this Word2Vector embeddings models only, Stanford University researchers developed one more model, that is a GloVe model. What is that? That is a GloVe model. So how this model is going to predict? This model is based on word co-occurrence statistics. So this will be based on what? Word co-occurrence statistics. It looks at how frequently a word appears together in a large amount of data. So this helps us more global relations between words. In order to identify that, it will be very helpful for us. Whereas in this contextual based embeddings, one more, one more embedding came. So that is ELMo. This is the famous embedding where it will generate you vectors based on the context. Based on the context. Let's say if a single sentence having same word occurred two times, or in multiple sentences I have same word occurred two times, then based on the context for the same word multiple vectors have been generated by this contextual embedding, so that we can able to understood so what is the pattern or what is the word relation or word meaning in that sentence. So this is how this contextual based embeddings will be. So don't worry, we'll look at examples as well for this Word2Vec embeddings as well as this contextual based embeddings. So before going to example, let's make it clear that how ELMo develop. ELMo model will develop the embeddings. Let's say I have two words. I went to the bank to deposit money. So this is one sentence, and the another one is the river bank is beautiful. So if you consider the both sentences, in both sentences I have bank word, right? Yes. What happens if I give those two sentences to this ELMo model? If I give those two sentences to this ELMo model, for the bank, for the bank word, it will generate different vectors. What it will do, it will generate different vectors for the same word. What is that word? Bank. Based on the context, they will generate. In the first example, bank refers to financial institution, whereas in second example, bank refers to side of river. So like that, it will generate the vectors so that it can able to understand. ELMo solves this issue by contextual embeddings through a bidirectional LSTM trained on large data set. Now, let's see an example of Word2Vec. So for this, in order to train my model, first I want some sentences. So that's why I'm creating a sentence variable. sentences. So in this, in the form of a list, I'm storing my sentences like I love machine learning. Mhm. I love machine learning. So like that, I have taken one sentence, and I enjoy deep learning as one more example. One more sentence I will take, and AI is the future. That I take it as one more sentence. Now I have written all the sentences that I want to use to train my model. So first, for for an example, I want to train Word2Vec model. First, what I'm expecting, I want to train Word2Vec model. So for this, from where I'll import this? So first we need to import this. From where I'll import this? From gensim dot models. You have this Word2Vec model. You can see, yeah. So in order to access this Word2Vec, first you need to write the command like pip install gensim, so that this will be installed at first. Then after you can able to import this. Since I have previously installed, it was showing me like all requirements have been satisfied. Now I've imported this Word2Vec model developed by Google. Now I want to train that model with the given with that sentences I have. So in order to train my model, you can write Word2Vec of. So by using what sentences you want to train, that sentences you need to provide. And what is the vector size? Let's say I want to provide a vector size is 10. Each vector size is 10. And what is your window size? Let's take an 2. And what is the minimum count? Let's take 1, and workers I'm taking as 4. So like this I'm taking. And the model, since this is model, I'm assigning this model to one of the variable that is with the name model. Okay. Now, so by using this model, what I want to get a vector from the word. So in order to get vector for a word, in order to get a vector from a word, then you can write this model of WV, Word2Vector of, for which word you are expecting vector. Currently, in this example, you can see for this learning, I am expecting the vector format. So that's why I'm writing this Word2Vec of this learning. Then first I want to print this to see the vector representation of this word, vector representation of this word learning. So that's why I'm running it. You can see, yeah, this is the same file name I provided, pyspace file name.py. Now I'm running it. Yeah, you can see these are the vectors generated for this learning word. So who generated these vectors? This model. Which model? Word2Vec model. It's model developed by Google, where it represents the given data in the form of vector. So this is one of the way to represent the given sentences or text or word in the form of vector by using this Word2Vec model. Whereas first you need to train this model with your data, and you also even generate the similar words that come with this letter, with this word. Now let's generate the more similar words which are coming with this learning word. If you observe in our sentences with this learning, what words will came? This machine came, and with this learning, this deep also came, right? Yes. So let's observe, or you can say let's find similar words to learning. Now I'm just printing the similar words to learning word are. So yeah, let me print those. So in order to print that, you can use the same format, that is model dot wv. You can use the model to convert the word to vector and identify the most similar words, right? So for that, you have this most similar, and there you need to provide the word learning. Yeah, I provided this. Now I want to run this to see the most similar words which are coming with this word. You can see most similar words here. If you observe, so these are the most similar words which are coming with this word vector, or you can say with this word learning. You can see here for deep as well as machine, since they come adjacent to this, or you can say similar to this word. So by this you can able to identify the similar words. So what happened? This word to vector learns the deep as well as machine, deep and machine, that is this deep and this machine often appears with this learning. So they get similar vector representation. You can observe. The vector represents the semantic meaning of the word. So this is how you can able to find the most similar words to the word, and you can able to identify the next upcoming word by using these Word2Vec models. By using this Word2Vec, learns word embeddings by analyzing a large amount of text that you provided, and words used in similar context get similar vector representation. For example, you can see, you have seen this machine and this deep have almost similar vector representations, and this model uses actually two main models, that is CBOW as well as skipgram. So this is all about this Word2Vec. So before you are getting the vector for a word, first you need to train your model with some data. You can see we have trained our model with some data. Then we are using that model in order to get the vector for the given word, and we also identified the similar word to the given word, right? Yes. So then we'll see the next example of now we will see the another model, that is GloVe based model, GLOVE based model, that is developed by the Stanford folks, or you can say researchers. Now, unlike word to vector, this GloVe based approach is based on word co-occurrence statistics. It looks at how frequently words appear together in large data set. We need to provide the large data set. In that large data set only, it will identify the co-occurrence of words. So based on that statistics, now let's take an example of this GloVe based pre-trained embeddings. So it is impossible for us to load all the data sets. The reason behind this is, so in order to load a huge amount of data set like 50 billion data or Wikipedia whole data, we do not have that much of compute, or we do not have that much of flexibility of compute to train our model or to load our model. So what we do, we will pick the data which is already converted, that is Word2Vec converted data that we pick, and we will utilize that data in order to use in our GloVe based example. So where that type of data is available, sir? That converted Word to vector data is available in this GloVe. You can see under nlp.stanford.edu projects under GloVe. If you open it, you can see it has the already available Word2Vec pre-trained data. You can see now I'm downloading this Wikipedia data, that is this GloVe 6b.zip file. I've already downloaded it. You can see that, yeah. So here I've already downloaded it. If you open this, then it might contains like this 50D data as well as like this. It also has 50D, 100D, 200D and 300D vectors related data based on parameters. Multiple files are there. Due to storage issue, I deleted all the others. I only I only had the required one, and this I have copied and stored in the same location where my code is there. You can see this is the file. This is the file. If you open it like this, many words are there, and the words related embeddings also present here, right? Yes. What words as well as the words related embeddings are corresponding embeddings are stored in this. Now we will use these words as well as those word embeddings in order to predict the word embeddings of our data, of our question, of our input that we provide. So now we will use that pre-trained GloVe vector. Since the training of that GloVe from scratch is resource intensive, so we are downloading it from GloVe website. Now first we need to load that data. So first I specify I want to tell where my GloVe file is. So I'm writing the GloVe file, that is this. So that's why I'm copying the name of it, and I'll store the name there in this variable. This GloVe file variable contains the our downloaded file name. Then first I want to load my GloVe data into a dictionary. Load my GloVe into dictionary. So I'm creating one empty dictionary with the name embeddings, and in this embeddings I want to store that data. So first I want to open this file. In order to open it, I'm using with open of, I'm providing that file name, that is nothing but GloVe file. In the read mode I want to open, so that's why I'm writing R. And since it's a encoded data, since it's a decoded data, I want to encode it. So that's why I'm writing encoding as UTF-8. And so I'm just opening this file, or you can say I'm saving this opened file as F. And by using that F, first I want to pick each and every line present in this file. So for each line present in this file, I'm picking each and every line. And so in that line also, I want to split the data. I want first the word as well as vector, right? So that's why I'm splitting the values and storing in values variable. Line dot split. I'm using line dot split in order to split the data based on the space between them, and I'm storing the data in values variable. Now values contains a list of data where the first letter is nothing but the word, and all the other elements in my list is nothing but my word vectors related to the word. So first I want to store the word in one variable, so that's why I'm writing word is equals to values of 0. The first element in this values is nothing but my word, so that's why I'm storing it in word variable. And I want vectors as well. So where my vectors are. Vectors are nothing but all the other values other than first value, all the other values are nothing but vectors in my for my word. So that those vectors I want to store it in this vector variable. So I'm just using a numpy to store the data in the form of array. So that's why I'm importing a numpy first. I'll import numpy as np. Then I'm using the np dot as array of all the values. So what are the values I have from 1 till end? So those all I'm taking, and the data type is it's a float type data. I'm storing it as float of 32-bit data. I'm storing the data. And so in this dictionary I'm storing for this word, these are the vectors like that I'm storing. So embeddings of word, for that embeddings of word I'm storing the vector. Okay, I'm storing the vector. Now in our embeddings, the data that we picked got stored successfully. You can even print and check whether the data got stored successfully or not. So for this, I'm just printing these embeddings, and now I'm just running this to show you all the data is stored in my embeddings dictionary or not. It will store no as per our code, these embeddings variables store each and every word and their corresponding vectors which are present in this file. And now those we are printing from here. So just wait a second so that this process will be completed and we'll get the response result. I think since a lot of data is fed into these embeddings, so that's why for providing the response, it may taking me a lot of time. I'm just clicking on Control C to get the response of particular value. Let's say I want to see the embeddings of learning for a variable learning. I want to get the embedding, so that's why I'm clicking on embeddings.get of learnings learning. Now I'm just rerunning it to see the embeddings of this variable. So let's wait for a moment so that this whole data, whatever the data present in it gets loaded. You can see we got the response. Now all our data gets loaded into this variable, and then from that variable we are getting the embeddings of particular word. You can see for the particular word, these are the embeddings. We can even check with the similarity. Now we got the embeddings, right? Yes. Let's write this. Here what we did, get vector for learnings, for learning. Now what I want is I want to check the similarity, check the similarity between two words. So how to check the similarity between two words? So in order to check the similarity between two words, we need to use dot product of two vectors by normalization. That is, we need to check that similarity by using any one of the similarity. Let's say I want to choose cosine similarity. I'm using cosine similarity to check the similarity. So what is cosine similarity? That you need to define first. So I'm just defining cosine similarity of two vectors v1 comma v2. Let's say if I pass two vectors to this function, then it will identify the similarity and send that similarity back. So what it will return is numpy dot product of those two vectors v1 comma v2 by normalization. So we need to import that normalization as well from numpy itself. To check the similarity, we are requiring that normalization, so that's why I'm importing that from numpy dot language algorithm I'm importing that norm as well, norm parameter as well. And now I'm using that in order to find the normality of my vector v1 and my vector v2. So this is the formula dot product of v1 comma v2, or by normalization of those two vectors will provide me the cosine similarity. I want to use this to find the similarity between two words. Let's say king and queen. Those two are similar words, right? Yes. So I want to identify the similarity between those two words. So I'm sending the cosine similarity of those two words, king and queen. So here we do not send the direct words. We need to send the embeddings of those two words. So embeddings of king to get the vectors of this king word, and embeddings of queen. So what does the embeddings mean? We are converting the word to vector, and then we are sending the vector of this king as well as this queen to this cosine similarity, and here actually it will identify the cosine similarity and send the response back. Now I'm just printing the cosine similarity between them. So similarity between king and queen. What response I am getting, that I am printing here, similarity. So that's it. Now I am just rerunning it to see the cosine similarity. If you observe the output, yeah, currently it is running. You can see the output. If you observe the output, then king and queen are related. The similarity context in many texts, through high cosine similarity we got the response. This GloVe actually focuses on global co-occurrence patterns, which means what appears together frequently in the whole data set that we provided with similar vectors. In this way, you can able to identify the similarity between two words, or you can even get the high or common similarity words by using this as well. Actually, by using this GloVe, you can able to convert like this vectorization, this word to vector conversion you have seen, right? Yes. In previous example, you have seen word to vector conversion. You can see, so from here you converted word to vector. Here you provided the data, and in now that is a GloVe example, you have taken the data set, pre-trained data set, and by using that you identified the vector representation of particular word, right? Yes. So in this way, by using a word to vector, you can able to convert, or GloVe, by using GloVe you can able to convert word to vector. Till now, we have seen examples for converting from word to vectors. So if we provide a sentence, does these word to vectors can convert? No, these word to vectors cannot convert a sentence into vector. You can see I'm just providing two words like learning Python. So forget about whole sentence. Let's provide two words and try to check whether it can able to convert to vectors or not. Now I'm providing this, and these are nothing but yeah, sentence embeddings, right? Yeah. Now I'm providing this, and yeah, now I'm just saving this change, and now I'm just rerunning this GloVe model. Let's check whether this GloVe model can able to generate me the sentence embeddings or not. You can see what we are getting the response we are getting as none. So from this, what you can able to say, these models can able to generate only word to vectors. We have tried with this GloVe based model where it is not generating me the vector for sentence that is more than one word. It was not it was not or unable to generate me the vectors. Let's open this Word2Vec model and let's try to provide some more input to this learning AI. Like that, I'm providing the input, and let's try with generating, or let's try to run so that this can able to generate or not. Let's check whether this can able to generate me the vector or not from the word. You can see what we're getting. Key, that is whatever the input that we provided, learning AI, that is not present. So this model also cannot able to generate me the responses, or yeah, let's provide one more thing, that is after learning, let's provide AI so that it can able to recognize this. And if we try this model again, so now also you'll get the same response, because this model is designed to generate word to vector, not sentence to vector. So that's why we are unable to generate vectors from the given sentence by using these models, that is Word2Vec, or by using this GloVe based models, we are unable to generate vectors from sentence. Then this model came. What is that? This ELMo model came. By using this ELMo model, you can able to generate vectors directly from sentences. Now let's try to send the sentences, or let's first create the model and let's try to send the sentences to this model, and let's see whether we got vectors or not. So first we need to load the model, right? So first I want to load ELMo model from TensorFlow Hub. I want to load my ELMo model. Where it is present? It is present in TensorFlow Hub. So that's why I'm importing TensorFlow Hub as hub. I'm importing it. And yeah, so first by using the TensorFlow Hub, you need to load your ELMo model. So for that, you first need to install this TensorFlow Hub. I've already installed it. I think I'll get the status like requirements are already satisfied. Yeah. So I've already installed it. So that's why I'm not getting any error. Now I want to load this. So I'm using a hub.load of, you need to provide some URL, that is https://TensorFlow Hub dot development. In this, Google/ELMo/3. So I'm providing this URL in order to specify the model, ELMo model. If you want to see some more details about this model, then just open your Google and type this URL and search for it. So that I think, yeah, we typed the wrong spelling. Here we need to type a GOOGLE. Yeah. So now it will open me the ELMo model with version 3. You can see this is the version we specified, and this is the variation we specified, that is ELMo model from this TensorFlow Hub. Okay, now I want to use that, so that's why I'm using it. Yeah, let me provide the correct spelling of Google. Yeah. Now I want to load it into particular variable, that is, let's say since it's a ELMo model, I am storing it in ELMo variable. And now, so first what I'm expecting, I want to send some sentences, and then I want to get the embeddings or vector for the whole sentence, right? Yes. So in order to get that, first I want to standardly define a function to get ELMo embeddings. To get ELMo embeddings for a sentence, I'm just defining one more function, that is ELMo underscore embeddings of, I'll send some sentence to this function. What it will do is it need to return me the embeddings. So how it will get the embeddings is we need to use that ELMo model. So to get the embeddings, you need to use ELMo dot signature. ELMo dot signature of, I'm using the default signature, and I'm providing some more parameters, that is a TensorFlow dot constant of sentences. Here I'm specifying the input of sentence, and then what I'm picking is I'm providing this ELMo. Yeah. So now you can see I'm generating the embeddings by using this. Here I just specified this sentence. I think we need to we need to define this TensorFlow as well. So that's why I'm importing this TensorFlow as well. Import TensorFlow as TF. That TensorFlow also you need to, the TensorFlow also we need to install. So that's why I'm writing pip install TensorFlow. Already I've installed it. So that's why I'll get requirements are already satisfied. Okay, now, so by using the model, I'm specifying the signature of the model, and I'm providing whatever the sentence that I want to convert, that I have provided as a TensorFlow constant, and specifying the ELMo, and whatever the embeddings that I get, that I'm just using NumPy to get the embeddings from the whole data. I'm getting the embeddings by using this NumPy. So first, let's provide the sentences, or let's pass the sentences to this, and let's check whether this function can able to generate vector for whole sentence or not. So for that, I'm just using the function name ELMo embeddings of, I'm specifying the sentence, that is I went to the bank to deposit money. So let's try to run it so that we can able to see whether this model can able to generate me the response for this model or not. You can see I'm providing the I'm providing the file name for this whole sentence. Let's see whether this model can able to generate me the embeddings or not. And then we also validate that for two different words, for two different sentences, how the embeddings will be generated. Those two are different or same. So I think we got some mistake here. Let's correct it. Signature. Do you mean signatures? Yes. So it's actually signatures. It's not signature. Yeah. Now I'm just saving and rerunning this code. First, it will load this ELMo model that you specified. This is the version 3 ELMo model from the TensorFlow hub. Then it will send this sentence to this model, and then it will find the embeddings. Now you can see it was generated me the embeddings, right? Yes. So it was successfully generated me the embeddings. So for the sentences, this model can able to generate me the embeddings. So let's store these embeddings in one variable, and let's try to provide same, or let's try to provide another question, another sentence to identify whether this model is generating me the same type embeddings or different. Embedding 2. Here I'm sending the another sentence. That sentence is, the river bank is beautiful. So as per we discussed in previous example, I went to the bank to deposit money. The river bank is beautiful. For these two, I need to get that different embeddings. So let's print the embeddings for those. So these are ELMo model embeddings. So that's why I'm providing some This embeddings one is nothing but financial context of bank response. And let's see the another one, that is let's see the ELMo embeddings for embedding 2. This is nothing but related to river context. So that's, let's provide that in river context. Yeah. Now let's run this so that we can able to observe the result, whether we got the same result or we get the different result. Observe carefully. It will generate me the different embeddings. The reason behind this is these model will generate sentences based on, or this model, this ELMo model will generate embeddings. You can see different embeddings have been generated, minus 1 point something, and here minus 0 point something is there. So it will generate me the different embeddings, right? Yes. So it will create, this ELMo model creates different embeddings for bank based on sentence, context. This makes it better than Word2Vector and GloVe for tasks like question answering and chatbots. You can even observe the difference between these two, because these are different contexts of a bank, and the word is same bank, but due to different contexts, different embeddings got generated here, right? Yes. You can see in second embeddings, we passed the sentence with 5 letters. So you can see 1, 2, 3, 4, 5. 5 vectors got generated. For each and every word, 1 vector is there. Bank is the third word. You can observe 1, 2, 3. So this is the bank. This is the embedding related to bank. And if you similarly observe, where is the bank? So from last 1, 2, 3, 4, fourth one. 1, 2, 3. Yeah, I think it is not visible. So this is how. So if you observe the overview of this, now first we loaded this ELMo model from this URL. Then we just created a function to create the embeddings for the given sentence. This ELMo model can able to create the vector for the given sentence, whereas these Word2Vector or this GloVe based models are unable to create me the vector for the whole sentence. So that's why we are using this, or you can say this model got developed in order to generate the embeddings for whole sentence. Now these are generating me the embeddings for whole sentence. You can see the result as well. I'm just removing this filtering. Now I'm just rerunning it. You can see it will successfully generate the embeddings for these two sentences. Then we'll even compare the word embeddings. We'll even get the word embeddings and we'll compare the word embeddings, whether they are same or different. Since we used the same word, that is a bank, in two different contexts, let's check with the embeddings of these two contexts as well. You can see for the given sentence, for the given sentences, it will generate the embeddings. You can see, yeah, this is the first first sentence related embedding, and this is the second sentence related embedding. Now I want to compare the bank related embeddings. This bank is nothing but, so which word in this, if you observe this, totally 1, 2, 3, 4, 5. 5 vectors of, or nothing but 5 list of integers as a vector we consider. So 5 vectors we came here 1, 2, 3, 4, 5. For 1, 2, 3, 4, 5. For 5 word sentence. If a word contain 5 words, if a sentence contains 5 words, then what is the length of these vectors? How many vectors I get? Totally 5 vectors I get. So in order to get this bank, what I'm doing is I'm filtering only that bank related 0. So this is nothing but the 0th sentence. So that's why I'm picking 0th sentence. It will pick me the 0th one in this list. Then 2. What does the 2 represents? The index starts from 0, 1, 2. This will pick the bank. Nothing but 0, 1, 2. It will pick this and it will represent me. And here, if you observe, since this bank related embedding is not displayed, so that's why I'm filtering. This bank is nothing but 0, 1, 2, 3, 4, fourth position, or you can say fifth word or fourth position word this bank is. So that's why I'm finding this. And now let's rerun it so that this bank related embeddings in this sentence will be printed, as well as in this sentence also printed. And let's check do we got the same embeddings for this bank word, or different embeddings do we get for this same bank word. Actually, it will generate us the different embeddings. The reason behind this is based on the context, it will generate me the embeddings. You can observe there is a huge variation in the float values it was generated. So based on the context, it will generate me, this ELMo model will generate me the embedding vectors. So that's why these type of embedding, ELMo model embeddings are better in question and answering, text generation, or you can say conversation chatbots compared to this GloVe based model or vector based models. Now at last, let's wind up this session with a small comparison or similarities between these. So you can see the creators. This Word2Vector is created by Google, and this GloVe model is created by Stanford University researchers, and this ELMo model is created by this Alien NLP AL2. And then coming to training methods, this is context window based training, that is a SIBO or skipgram, that is Word2Vector. Whereas coming to this GloVe based models, these are trained based on co-occurrence matrix, whereas these ELMo models are trained by using bidirectional LSTMs. Here we are not trained this model, we just picked the model based on the version by using the URL. Here in this GloVe also we haven't trained this model, we just picked the data, or you can say we just picked the available trained data set. Whereas here in this we actually used the function name in order to get the context gets trained. And coming to contextual embeddings, that contextual embeddings will be generated only by this. Whole sentence embeddings will be generated by this. Whereas coming to these two, these will generate only word related embeddings. Coming to words representation, in this one vector represents one word. So here also one vector represents one word. Whereas coming to here, for the same word, you have seen different vectors have been generated. In the example, you have seen for the single word, for the same word, that is a bank, you have seen different vectors are represented. So at last, let's see the use cases of these. Coming to this, that is this Word2Vector, this is a major use case of this is word similarity and analogy. For that, this Word2Vector embedding model is useful, whereas this GloVe model is majorly useful for global word relations, whereas this ELMo model is used for context sensitive tasks. So that's all about these embeddings era. This Word2 vector and GloVe provides you statistic embeddings, the same vector for the word, regardless of this context of the word. Whereas this ELMo gives you contextual embeddings, make it more powerful for complex NLP tasks like question and answering and named entities recognition. So like that. So this is all about this embeddings era, evaluation, as well as the types classification, as well as the utilization you have seen with the code, and you have seen the major difference between them. So this is all about this embeddings era and comparison between different models. I hope this video is useful. If you feel this video is useful, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye guys.